Welcome back. Today we're going to continue our study of Unit 3 with rotations. You're going to need your packet, an erasable pencil, a ruler, and a protractor. If you don't have one of those, hit pause and go get one. Ready? Great. Let's go. A rotation is a turn around a point. So one of the first things we need to do is talk about how we measure turns, or what's called an angle of rotation. We can turn counterclockwise, so counterclockwise or to our left, or we could turn clockwise to our right. Now, since clockwise and counterclockwise usually work only well for clocks, in mathematics we came up with a numerical definition, which is that if you're turning to your left, that's a positive angle. So like for this, it's about a 60-degree angle. If you're turning to your right, that's a negative angle, saying we're going in the opposite direction. So this would be like a negative 40-degree angle. Now, if you're not turning at all and you have a rotation of 0, that's called the identity transformation, or the transformation you do to just know who you are. So let's take a look at a specific example of a rotation. So right here we have the pre-image, which is this solid thing right here. We have the image, which is the dotted line right here. We have a center of rotation at P, and we have an angle of rotation, which is A, around P to what's called A prime. And so we can see that the rotation is a turn from the point A to A prime around the point P. Let's actually look at an example here. Looking at example 1, we have a pre-image, which is a solid line right here, that's been turned to create this image. The center of rotation is P. The question is, how do we then find the angle of rotation? And this is where your a protractor and ruler come in handy dandy. What we want to do is we want to imagine that this point was clearly turned to meet that point. And so the angle we're looking for is this angle right here, from here to here. So in fact, let's go ahead and use our ruler to draw that angle, making sure we go through the center of each point, be as precise as you can, measure twice, cut once, all that good stuff. Then set the other one. And taking our handy dandy protractor, we set the 0 on the vertex. We line up this one side with a base, and then we start up here from 0, 0, 10, 20, 30, 40, 50, 60, 70, 80, and then this is just shy of 90. It looks like it would be 88 degrees. 88 degrees. 88 degrees counterclockwise. Now, since it's counterclockwise, as we looked before, that means it's positive, so we would leave it positive. If we were measuring it this way, we might be at a negative result. What about over here? If I have the triangle ABC, and it's been rotated to the triangle A prime, B prime, C prime around the center D, how do I then measure that angle of rotation? Well, it's kind of the same process. I can use my straight edge to match. Let's say I want to use C as my measurement, because why not? So I'm going to connect C to my center of rotation, and then its image C prime to my center of rotation. And that gives me a nice clear angle that it must have traveled. Now I can estimate that looks like it's 60 degrees, but let's actually measure it. So again, we put the center of the protractor on the center of the angle, line up one side, and then you count again from 0, 0, 10, 20, 30, 40, 50, 60. It actually ends up being almost exactly 60. Do you see how 60 then lines up right there with that side? So the angle of rotation is 60 degrees, and this is clockwise. Now another way of writing this down would be minus 60 degrees. Both of those would be considered correct. Now the notation for a rotation is R for rotation, and then below the line, kind of underneath, is C for the center. So around the center, in this case, it would be kind of like this R here, or the D here, or the P up there. And then this funny thing is called a theta, which is like X for angles. It's a way of saying an unknown angle. So the way I would write this rotation up here is I would say rotate around the point D negative 60 degrees. And that's how I would represent this rotation right here. Now, if we look at this in a kind of more detailed way, let's again look at this measure right here. We've taken this quadrilateral and we've rotated it over to here. Now, they're suggesting that we measure AD A prime. So using our handy dandy protractor, we're going to measure out A all the way to, let's see, or really if they want us to do A D prime right there, we should line up our 0 with A, and we can extend this out so that we'll be able to see it. Add in an auxiliary line there, make sure it's all lined up. See how I'm making sure that you can just see it just above the edge of my ruler? That helps it be very closely lined up. Extend that outwards. And then line this up like so. And then 0, 10, 20, 30, 40, 50, 60, 70, 75 degrees. So 75 degrees in a clockwise direction is negative 75 degrees. Now, what happened to angle D? Well, the angle at D seems to stay the same time. I think what they're saying right there is A has an A prime, and B has a B prime, and C has a C prime, but wait a second, there's only a D prime here. It's at the same place as D prime. Angle D and angle D prime are at the same location. Since we can see that D is the center of rotation, therefore mapping D onto itself. So when I turn this whole shape, because I'm turning it around the point D, whatever's at the center stays at the center. Now, did we get the same angle measurements if we measure B, D, D prime? We should make sure that's the case. Take a moment, hit pause, measure it yourself, and see what you see. Did you get negative 75 for all of them? What this means is that it doesn't matter which original and which image I use to measure the angle of rotation, as long as I'm consistent between the two shapes. In exercise 2, they actually apply that in the sense that you say if E is the center of rotation and I'm rotating this from here to here, I could either measure DE D prime or CE C prime, and I would still get the same angle. Now, the last skill I want to talk to you about is how to find the angle of rotation, not only the angle of rotation, but the center of rotation. So you see this M right here? The M has been clearly rotated from here to here. The problem is, I know that the answer is probably going to be here's my center of rotation, but I don't know where exactly it is. So to make sure I can do this, I'm going to need my trusty ruler, and I'm going to need my compass. It's been a while since we've used this, so let's pull that out. And let's follow the step-by-step process. First it says, draw a segment connecting A to A prime. Now it doesn't necessarily have to be A and A prime. I think it's just basically connect a image and its pre-image. Now, find the perpendicular bisector of that statement. Now remember, perpendicular bisectors are found by finding the points that are equidistant from both sides. It's been a while since we've done this. Let's just, refresh our minds for that. And then measuring it from this side as well. Take your time, do this right. And connecting the two ends, I'm going to use, let's see, do I have a pencil around here? Well, no pencil. I'm going to very lightly draw this in because I'm going to need to do some other work. I want to make sure I don't confuse my lines. There's my perpendicular bisector. Now, draw a segment connecting B and B prime. Again, we're doing that connecting a pre-image and an image of the same point. All right, let's try and do that as precisely as we can. The more precise we are, the better we'll be able to. All right, now pull that in. Now repeat from the other side. Looking for the intersections. Now it's very easy to get confused which intersection you're using, so it's sometimes helpful to mark the relevant intersections like so. And then draw in your perpendicular bisector. Again, you can do it very lightly. Now, this right here, the point of intersection between the two perpendicular bisectors is the center of the rotation. Right here, P, right in that area that intuitively we knew was going to be the case, that's the center of rotation. Justify your construction by measuring A, P, A, and B, P, B prime. Do you obtain the same measure? Check it out and let's discuss it in class tomorrow. Have a wonderful rest of your day.